PostgreSQL CDC. For the initiated, those words might dredge up flashbacks. The wall climbing out of control, lost replication slots, trying to find your place again with yet another backfill. There's no denying that Postgres change data capture can be tricky, but a little knowledge can go a long way. In this video, we'll cover what CDC looks like with Postgres, why CDC is so important in the first place, and how to simplify your setup with Estuary. No Kafka required. PostgreSQL, or Postgres for short, is one of the most widely used relational database systems. It's an open-source transactional database, which means it's optimized for writes, perfect for an application backend. Postgres includes a lot of flexibility, so you can customize it to cover many use cases. However, this customization can also come with a complexity cost, including when it's time to get data out of Postgres. Why would you want to move your data in the first place? Because Postgres often backs a live application, you want to keep extraneous queries to a minimum. Long-running analytical queries, or frequent select-alls, add load to the production database. This, in turn, can slow down incoming transactions, or even cause query timeouts, negatively affecting end users of your application. Postgres is therefore often paired with an analytical database, like Snowflake, ClickHouse, or an Iceberg lakehouse, that's optimized for more complex queries. Instead of trying to do everything within the production database, you can replicate data to the separate location. So how do you make sure that the replication itself doesn't negatively impact your Postgres instance? The answer is often CDC. CDC, or change data capture, is a method to record all changes made to a database as they occur, including inserts, updates, and deletes. CDC can encompass several techniques, but for our purposes, we'll stick with what most people probably think of when they hear CDC, a log-based approach. Because CDC continuously tracks updates, it has a lower impact on the database than a large bulk query, especially since you're not rereading or reprocessing data multiple times like you would with an inefficient scheduled select statement. And since CDC follows along as updates occur, it opens up real-time capabilities down the line. True real-time analytics in your destination rely on real-time data from the source. This is one case where batch just won't cut it. Change data capture also offers the most complete record of a database's history. Batch captures can only offer a snapshot of what the database looks like at a certain point in time. In contrast, CDC can capture rows that change status multiple times or were created and deleted between batch query events. In short, CDC is especially useful for situations where you need real-time data replication, such as for real-time analytics, complete change event records, such as for audit logs, or low-impact replication for critical production databases. With Postgres, you can implement log-based CDC using the wall, or write-ahead log. Every Postgres instance has a write-ahead log that stores modifications before they get applied to the database. This enhances transaction durability and also allows us to follow along with changes for replication. Peeking into the Postgres wall adds a complication, though. Postgres wants to clean up the wall to free up space once logs are no longer needed. But Postgres doesn't necessarily know when we're done with a log. Instead of keeping the log around forever or accidentally discarding it early, causing our CDC replication to lose some data, Postgres has us use a replication slot. The replication slot is like a cursor or bookmark in the write-ahead log. As we read data for CDC, our replication slot advances, and the Postgres database clears the no longer needed wall data. This comes with a drawback. If your CDC solution can't keep up and your replication slot falls behind, the write-ahead log builds up, fast. The wall rapidly eats into allocated database storage. And if storage completely fills up, regular database transactions will not be able to complete. Game over. Or, in some Postgres configurations, when the wall exceeds a certain size, the the replication slot gets dropped entirely. A last, desperate act to rein in the wall. Just like that, your complete change history for your audit log is toast. You can backfill data based on the current state of the database and set up a new replication slot, but you won't have that direct wall record from the intervening time. Implementing CDC therefore comes with its own set of challenges. If you're creating a solution from scratch, you need to code defensively to account for the unhappy path. For example, because of concerns around wall buildup, it's often best practice to decouple Postgres from your destination system in your pipeline. That way, if you're compiling scheduled batches of source data to load into your destination, you're not letting the wall build up in the meantime. Or, if your destination has an outage, you're not stuck until it comes back online. Let's put this theorizing into practice. I'll demo Postgres CDC setup with Estuary, and note where to branch off if you're implementing your own CDC solution. Estuary is a real-time and batch data movement platform that handles CDC management for you and lets you set up pipelines to multiple destinations with plug-and-play connectors. You get CDC's low latency efficiency without the complexity of DIY Kafka-based setups. However you choose to implement CDC, there are some common configuration steps to prepare your Postgres database for replication. Number 1. Setting your system's wall level to logical. Logical replication will make your Postgres wall data more portable, essentially formatting it into the insert, update, and delete events you'd expect to see. Apply an alter system statement to set wall level to logical and restart your database for this to take effect. Then you can create a special database user to handle replication. Either alter an existing role or create a new one with replication. Make sure to grant other privileges as appropriate, such as granting PG read all data or granting select on certain tables. You will also want to create a publication for the tables you're replicating. The publication will group together tables intended for CDC and ensure that changes to these tables are marked for replication. You can branch off here to handle logical decoding and routing your data if you're implementing your own CDC solution. And if you are, good luck. The rest of this video will focus on setting up a Postgres CDC source with Estuary. To follow along, create a free Estuary account at estuary.dev. For Estuary, we have one more Postgres configuration step. We need to create a watermarks table. This acts as a small scratch space where Estuary can track progress, as well as a consistent heartbeat that helps the replication slot advance, even when there are no new changes in our publication tables. Add the watermarks table to the publication, and make sure your replication user can read it. With that, we can move to the Estuary platform itself. In the dashboard, create a new capture and choose a Postgres source, whether self-hosted or cloud-hosted. Give it a name, and start filling out connection details. These include the server address, or host and port, of your database, the replication user you created, and an authentication option. Besides directly inputting the replication user's password, you can also manage authentication via IAM to keep authentication management with your cloud provider. For a simple, straightforward setup, that's all there is to it. Or, for more particular use cases, there are plenty of additional settings to explore. For example, if you're using CDC for an audit log, make sure to select History mode to keep Estuary from merging change events together. And for more advanced configurations, you can modify settings to control backfills, specify the SSL mode, or work with read-only instances. When you're happy with your setup, click Next to discover available tables and their fields. By default, Estuary keeps schemas up to date as they evolve, and picks up new tables as they're configured for replication. Review the tables to ingest, and save and publish your capture. Estuary will start streaming data from tables into corresponding collections using CDC. These collections are replayable and backed by cloud storage, so you aren't tightly tying your Postgres source to your destination. You can replicate data to multiple destinations without rereading it from your production database. And if your destination goes down, whether due to a planned upgrade or unplanned outage, your wall won't build up in the meantime. Continue your pipeline by creating a materialization. Destinations include Snowflake, Iceberg, ClickHouse, and more, with options for batch or real-time data materialization. For real-time use cases, make sure your materialization sync schedule is set to 0 seconds for continuous data. Or if you're building an audit log, pair your Postgres captures history mode with Delta updates on the destination side. Understanding the what, why, and how of Postgres CDC unlocks a powerful tool for any data pipeline, while helping you avoid pitfalls around wall buildup and replication slot loss. Still have questions? Join our Slack community for discussion and support, or contact us at estuary.dev to get into the nitty-gritty of your specific use case. And if you found this video useful, subscribe for more data engineering walkthroughs.